Hello everyone, welcome to Shivi's chemistry classes. Today's topic is salts under the chapter acid bases and salts. So in this video we are going to study about salts and we'll be defining it and types of salts and properties. Mainly we'll be discussing about the solubility of salts. So we'll be covering all the topics one by one. So first we will go with the definition. So what is a salt? So we have studied earlier during the reaction of acid and base. We are getting salts as the main product plus water. So this is not a new term for you because we have heard of this term many times during the entire session of acid and bases. So while reacting an acid with a base, we are getting salt and water. So what exactly this salt is, that we have to cover in this topic. So the definition says salts are ionic compounds that contains a cation other than H plus and an anion other than OH minus. So what the definition says, that it is an ionic compound. Ionic compound means definitely it could be having ions. Ions are positive and negative charge species. Say for example, we'll take NaCl, the most common salt. So whenever this term salt comes, we immediately think of common salt, that is sodium chloride, or we can say the table salts. So you can see that this sodium chloride is formed with the combination of one sodium ion and one chloride, and this is positive species and this is negative species. So what the definition is saying, that it could contain positive and negative ion other than H plus and OH minus. So maybe it will have H plus and OH also, but apart from this, it is mandatory to have other cation and anion also for a compound to behave like a salt. So we'll take some more examples. Like one is the sodium chloride. This is sodium carbonate. This is sodium bicarbonate. And this is magnesium chloride, potassium chloride. This is basic lead chloride. Basic lead chloride, that means it is having a OH group, that means it is a base. So basic lead chloride, and this is basic copper nitrate. So these are all examples of salts. Now we'll see whether these examples are satisfying this definition or not. So here we have seen that yes, it is a salt because it is having positive and negative ion other than H plus and OH. What about this? Here also the condition is same. Positive ion is sodium and negative ion is carbonate. Here sodium, hydrogen and carbonate. Three species are present. So what the definition is saying, that it may have H plus also, but apart from this, yes, it is having one more cation, that is Na plus. So H is okay, and one negative ion other than OH minus is carbonate. So yes, it is also a salt. Here also true. One positive is Mg and chloride ion. Positive is K, potassium and chloride ion. What about this? It is having OH group as one negative species. Apart from this, chloride is also present as a negative ion, and here lead is acting as a positive ion. So yes, this is also satisfying the definition. Yes, it is also a salt, and same is the case with this also. What about this? Magnesium hydroxide. Is it a salt or simple base? So it is not a salt because it is having negative ion OH minus, but there is no other negative ion is present apart from this. So this is not a salt, this is a base. So by now you must be able to differentiate between a salt and a base. Okay. So once again, salts are ionic compounds that contain a positive and a negative ion apart from this H plus and OH minus ion, and these are some of the examples. Now we'll see Another definition, one more definition is there, that salts are formed by the um, they are formed by the complete or partial replacement of hydrogen atom, or we can say ionizable hydrogen atom of an acid by a metallic ion or an ammonium ion. Now what is this? It is formed by the complete or partial replacement of ionizable hydrogen atom of an acid. We know that presence of hydrogen is the most important thing for a compound to act as an acid. So acids, they definitely contain H atom or hydrogen atom. So to convert an acid into a salt, what is needed is that it should either lose its hydrogen atom completely or partially. Right? So let's take two examples. One is hydrochloric acid, but we know that acid react with base to give salt. So we have to take an acid and a base on the reactant side. So that is mandatory, because when they react, then only salt will form. One is HCl and another example is H2SO4. So what is happening here? That this ionizable hydrogen atom is completely replaced by this sodium or the sodium ion, or the sodium is matter, so that's why we say either metallic ion or a sodium or positive ion. So this is replaced and this sodium get attached to chloride ion and form a salt, that is NaCl and water. And here what is happening? This is an example of complete replacement of hydrogen, and here I'll show you how the partial replacement is taking place. So means this sulfuric acid, it is having two hydrogen atom, it will lose only one hydrogen atom to form water molecule and one will remain as such. So here the partial replacement is taking place. So what you are getting as a product? Both sides you are getting salt. So this is also one definition, both are true. Now we will see types of salts. Types of salts. First type is normal salt. Again, same example, when acid reacts with base, form salt. Means whatever acid or base you are taking, that could be of equal strength. Means complete neutralization will take place and then you will get salt and water. So in normal salt, complete replacement of hydrogen take place and the salt and water is produced. So that is called normal salt. You can take H2SO4, take another base, calcium hydroxide. You will get calcium sulfate as salt and water. So this is normal salt. Second type of salt is acid salt. So acid salts are formed by the partial replacement of hydrogen atom by a metallic ion or an ammonium ion. So if to make this partial replacement, you could definitely have to take an acid that contains more than one hydrogen atom, like H2SO4, NaOH, you are getting NaHSO4 plus H2O. So this is sodium hydrogen sulfate, sodium hydrogen sulfate, or sodium bisulfate you can say. Sodium bisulfate. So this is an acid salt, so you can see the presence of this H atom over here, that means it is an acid salt. Another example is Na2HPO4, this is disodium hydrogen phosphate. NaHSO3 also, this is sulfate, this is sulfide, sodium hydrogen sulfide. So these are some examples of acid salts. Now third is basic salt. Basic salt. So basic salt is formed by the partial replacement of OH group. So basic salt is formed by the partial replacement of OH group. Now we will take some examples of basic salts. Some examples of basic salts I am writing here. Basic lead chloride, basic magnesium chloride, basic copper chloride, basic copper nitrate. So these are some of the example of basic salt in which you can see the presence of this hydroxyl group. So let's take the preparation. PbOH twice. This basic salt, basic lead chloride is formed from lead, this lead hydroxide, no? So this is containing two OH groups. So to make partial replacement, you have to take that compound which is having more than one hydroxyl group. So then react it with, this is a base, and react it with an acid. So what you will get? PbOHCl. This Cl will come here and one OH will get removed as water. So this is basic lead chloride. So this is a basic salt. So for the one condition is required for the formation of this acid and basic salt. Means that in case of acid salt, the amount of base that you are taking is not strong enough for the complete neutralization to take place. So that is how this acidic and basic salts are formed. Means in basic salt, the resulting solution what you are getting is a base, is alkaline in nature. Means pH, its pH could be more than 7, whereas in case of acid salts, the resulting solution that you are getting is acidic in nature, so its pH could be less than 7. So now fourth type of salt is double salt. So double salt is formed by the union of two simple salts. See, the first three are important. Then next only you have to learn the names as an examples. Maybe you will be asked name one double salt, or give the example of a mixed salt, or you will get the example and you will be asked to name the type of salt. So first three are important. Next whatever I am teaching you, you just learn it. Okay. So next is fourth type of salt is double salt. Formed by the union of two simple salts. Union of two simple salts. Like three names you have to learn in this, but one is potash alum, moher salt, and dolomite. So what is potash alum? It is a combination of potassium sulfate and aluminium sulfate. Potash alum. Then moher salt and dolomite. Three names you have to learn in under the heading double salt. Potash, the one will be a potassium salt, K2SO4, alum is Al2SO4 thrice and 24H2O. This 24H2O is the water of crystallization. Water of crystallization is the water that get attached to the crystals while this is separating out from its solution. So it is loosely held, it is in loose chemical combination with the original compound, so you can easily remove it by heating the crystals. So this is the water of crystallization. Potassium sulfate, aluminium sulfate. From name itself you can have the idea that potash is potassium, alum stands for aluminium. So you have to make the salt. Simple salt is potassium sulfate, aluminium sulfate, and 24H2O is the water of crystallization. Then Mohr salt, FeSO4 is ferrous sulfate, FeSO4 is ferrous sulfate, then ammonium sulfate. And 6H2 is the water of crystallization. Then dolomite is calcium carbonate and magnesium carbonate. So these three examples you have to learn for double salts. We can see the combination of two simple salts to make it a double salt. First is potassium, potassium sulfate, ammonium sulfate, Mohr salt, ferrous sulfate, ammonium sulfate, and dolomite is calcium carbonate and magnesium carbonate. Next is mixed salt. One of the very important example of this is bleaching powder. Chemical formula is CaOCl2. Stands for calcium oxychloride. It could have more than one acid or basic radical. Mixed salt. So only name you have to learn. Bleaching powder or calcium oxychloride. And the last type is complex salt. Complex salt on ionization gives a complex ion and simple ion. Most of the time you will get this type of salt written in square bracket. So you could easily guess what type of salt it is whenever you get this type of example, like Na, AgCN2. This Cn is cyanide group, Ag is silver. So whenever it ionizes, so whenever you get this type of compound written in square bracket, so just make a guess that it is an example of complex salt. So whenever this type of salt ionizes, it gives a simple ion. Simple ion is Na plus over here, and a complex ion AgCN2 minus. So this is example of complex salt. This is silver ammonium chloride. Silver ammonium chloride. So this is also an example of complex salt. I hope this much is clear to everyone. Please make a note of all these things, whatever thing I am writing on the board. Keep on writing along with me to make the contents more clear or easy. So if you will write, then only you will be able to understand. Otherwise, everything will just vanish out from your mind. Now we have to see the properties of salt. First is they all are electrolytes. That means conduct electricity. So they conduct electricity, that is why they are called electrolytes. How they conduct? On dissociation, they break into positive and negative ions. They break into ions. So these ions conduct electricity. So that is why they all behave like a electrolyte in molten state or aqueous state. They are normally in the form of crystals. They are crystalline. Normally in the form of crystals in nature. Solubility. They are mostly soluble. Mostly soluble, and some are insoluble also. Now next, the solubility is very important topic, and most of the question that you will get from salts comes from this solubility. So we have to understand it very nicely. Now we will see the solubility of salts. Solubility of salts. Here I am going to write exceptions. All compounds of sodium, potassium and ammonium are soluble. All the compounds, whether it is nitrate or it is carbonate or anything or sulfate, so all these compounds of sodium, potassium and ammonium are soluble with no exception. Then all nitrates and nitrites are soluble. Nitrates and nitrites. So all the compounds of nitrates and nitrites are also soluble. All chlorides are soluble with exception lead chloride, mercury chloride and silver chloride. So these three chlorides are insoluble, rest all the chlorides are soluble. This lead chloride is soluble in hot water. Insoluble in cold water, but it is soluble in hot water. So these exceptions you have to learn. So all chlorides are soluble except these. All sulfates soluble except barium, calcium and lead. Except barium sulfate, calcium sulfate and lead sulfate. Rest all the sulfates are soluble. And fifth is all carbonates, sulfides, and phosphates are insoluble. All carbonates, sulfides and phosphates are insoluble. So what will be the exception over here? In the first point, I said that all the compounds of sodium, potassium and ammonium will be soluble no matter whether it is nitrate, chloride, carbonate, sulfide or whatever, but the compound of these three are soluble. So what will be the exception over here? Sodium, potassium and ammonium. So what here we are saying that carbonate, sulfides and phosphates are insoluble with the exception of these. These three are soluble. So in the next lecture we will be seeing the preparation of soluble and insoluble salts. Till then, have a nice day.